Express x squared minus 3x plus 5 in the form x minus p all squared plus q. Hence write down the equation of the line of symmetry of the curve with equation y equals x squared minus 3x plus 5. The curve C with equation y equals this and the straight line y equals x plus 5 intersect at the point A05 and at the point B as shown in the diagram below. Find the coordinates of B. Find the integral of x squared minus 3x plus 5 and find the area of the shaded region bounded by the curve C and the line segment AB. Okay, I've got this question summarized here then. Let's have a go at it. First thing is we need to complete the square with this quadratic here. So A part 1 then. So here, what have we got? We've got x squared minus 3x plus 5 is equal to, so it's going to be x minus something squared. Half of this is minus 3 over 2, isn't it? So that's what we put in the bracket. So we get x squared minus 3 over 2 minus another 3 over 2 will make the minus 3x. But when we expand this bracket, we'll get a plus 9 over 4. So we need a minus 9 over 4. And we've already got the 5 there, haven't we? So we better leave that as is. So that's equal to that. So what have we got then? This is equal to x minus 3 over 2 squared. 20 over 4 is 5. Take away 9 is 11 over 4. So there's the quadratic then, written in this form. Hence write down the equation of the line of symmetry, part 2. So let's just write it down. So here this will be the same around the point x equals 3 over 2, won't it? Because this is squared, so anything above 3 over 2 or the same amount below 3 over 2 will produce the same value. Part B. Let's have a look at part B then. Find B, the coordinate here, when these two curves meet each other. So let's have a look at that then. I'm going to use the quadratic here. So for part B at coordinate B, we've got x squared minus 3x plus 5 is equal to the line x plus 5. So let's have a look at it then. We've got x squared then. Move this minus x over to be minus x, so we'll have minus 4x equals 0. And then we can factorize out an x straight away, can't we? X minus 4 equals 0. And that tells us at B, that's when this value is 0, so x equals 4 here. And that would be at B, because the other point is at 0, isn't it? So x is 4, so y is equal to x plus 5, wasn't it, here? So it's 4 plus 5 equals 9. 9, and B has coordinates 4 and 9. So there's our coordinates for B. Find this integral then. So let's have a look at that. Straightforward integral. So part 2, the integral of x squared minus 3x plus 5 dx, raise the power by 1, divide by that number, minus 3x, raise the power by 1, divide by that number, plus 5 lots of x when you integrate it, plus a k, constant of integration. So that's part 2. And now find the area R. That was between the line and the curve. The line was above the curve, wasn't it? So here, this is part C. So here the area then. It's going to be the difference in the y values. Sum those differences between the x value of 0 and 4. The bigger value was x plus 5. The smaller value was this integral here, so I'm just going to write that in. It's probably the most straightforwardest way to do it, is do it in one fell swoop here, personally. So this would be the integral between 0 and 4 then. We've got x, we've got a minus x squared. We've got x minus minus 3x, which is plus 3x, so that's 4x. We've got a 5 take away a 5, so they cancel. So do the integration minus x cubed over 3 plus 4x squared, raise the power by 1, divide by that number. And that would be between 4 and 0. 2 goes into 4 twice, so let's just put that down here. So the area then, top value, take bottom value. Now the bottom value, put 0 in for the x's and you'll still get 0. So we can put that down straight away. Here we got 4 cubed. Minus 4 cubed is minus 64 over 3. And here we've got 2 lots of x squared. X is 4. 4 squared is 16. 2 16s are 32. So in terms of thirds then, we've got 32. Times that by 3, you get 96 over 3 minus 64 over 3. Which is equal to 32 over 3. And that would be in units squared, wouldn't it? Because it's a measure of area.